Well, we're trying to understand a wintertime ozone phenomenon. Typically, we associate ozone with summertime pollution within urban areas. But out here in the Uinta Basin, we have a unique situation where our most pronounced ozone episodes actually occur in wintertime. And so we've located our instruments here near the lowest point in the valley where we're going to get the greatest depth of the inversion, so that when we have those ozone episodes, we're getting the most relevant measurements for that particular episode.
For the activities we authorize in the BLM, several of them can produce air pollutants, including oil and gas development, emissions from fugitive leaks from well pads, including emissions from drill rigs and hydraulic fracturing operations. Those are the primary sources of the pollutants that create the air quality issues out here. So if we can better understand characteristics that lead up to the development of ozone formation and what sources are the most important to help form ozone, then we can better manage those sources that we authorize to impose controls and other requirements on them so they don't pollute as much. So here at ORE, we've set up a tower that can go up to 32 meters, and we instrument that with several instruments to measure temperature, pressure, humidity, winds. And with winds, we have both a mechanical anemometer, which has a propeller and wind vane, and also a 3D sonic anemometer, which can be used to also collect turbulence information to see what the small scale eddies, those micro scale eddies that help with the diffusion and dispersion of air quality pollutants at the low levels. In addition to the tower, we also have an acoustical sounder that sends a sound pulse up into the atmosphere, and that sound pulse reflects back off of turbulence and density changes in the atmosphere, and it can be used to back out the vertical wind speed, and that can see up to about 400 meters above the ground. Our final instrument that we have out here is a radiometer, which measures temperature and moisture profiles through the atmosphere, and that can see almost all the way up to the tropopause, which is several kilometers high above the ground. So, using all this data, we can then piece that together and monitor the inversions, how they develop over time, and how strong they get in the winter time, so that we can use that to improve our air quality models, how they represent the inversion in those models, and hopefully get better air quality forecasts out of it. Having a better management of our activities we authorize in controlling the pollutants, we can be better partners for the community out here to help them have cleaner air to live in, and to better understand the air quality problems out here in the Uinta Basin, do air quality modeling to see what controls would work best for limiting pollutants and prevent the development of ozone in the wintertime out here.
We have a number of reasons why we're concerned about air quality on BLM lands. Number one, we have a statutory requirement under the Clean Air Act and the National Environmental Policy Act to monitor air quality and make sure that none of our decisions are adversely impacting the environment. Secondly, a lot of the land management agency programs, such as soils or water quality, are affected by atmospheric quality, things like air pollution. And so if we better understand the way our land management activities contribute to atmospheric impairment and atmospheric pollution, we can better manage those lands for other values that we manage. And so anything that we can do to assure the public that we're making the most environmentally responsible decisions we can make while managing for multiple uses, we consider that a benefit.